So now that we understand the concept behind horizontal projectiles, why don't we talk about the math behind it? So this video is fairly long, so for the very first assignment, if you just want to worry about getting through creating the X and Y chart, that's what you need to be able to do in class. So just go through at least that point if you don't want to finish all of it. And then the following night, make sure that you finish up the rest of this in order to understand how to solve the problems. So here we go. So first, components. We talked about in the previous video that the horizontal and vertical components are independent. So the horizontal does not affect the vertical does not affect the horizontal. So we have to look at them separately. Gravity only affects the vertical, so we only deal with gravity in the vertical direction, or the Y direction. The horizontal, or the X, is at a constant speed. So important variables to know. This looks really yucky, but at the same time, you've seen all of these variables before. The only difference is now we're separating them into X and Y. So you'll notice here under X, we have Vx, dx, and t. Under the vertical, we have V naught y, Vy, dy, and t. The reason why there's no V naught x is because V naught x and Vx are the same. The velocity is constant, so the initial velocity and the final velocity, or the velocity at any point, is always going to be constant. So there's no V naught x. The only variable that these two have in common is time. So the way I like to say it is that time ties the vertical and horizontal together. So time ties the two together. The time here is the same as the time here because it's the same projectile in the same situation. So time ties. Important equations. Again, this looks really yucky, but you've seen all of these before. Notice here, since the velocity is constant in the x direction, you just need direct TV. See? Direct TV, dTV, dx equals vxt. For the vertical, since vertical involves gravity, we're going to use the big 4 with g replacing our accelerations. So g replaces a. And the only other difference between these equations and what we did in 1D is that we've got all these y's. That's it. If you take all the y's out, they will look identical to the ones that we've already done. So what does a marble look like when it's dropped? So it starts up here at the top, and then in 1 second it drops a little distance, and then in 2 seconds it drops a little bit further, and in 3 seconds it drops further, and so on and so on. So every second it's gaining distance. So small distance, larger, larger, larger as it's falling. So if we're dropping the marble, when the marble is dropped, what is its initial vertical velocity? So when you drop it, what is the initial velocity of a dropped object? Well, it is 0. The initial vertical velocity for a dropped object is 0. So V naught y is 0. So if this marble were dropped from 1 meter, how long would the marble fall before it hits the ground? Well, this is just one of those big 4 problems where we use the guess method. So we need to determine our givens, then our unknown, then find our equation. So to get us used to it, we're going to use those y's as well. So the first thing is it's dropped 1 meter. That's our d. So dy is 1 meter. Now which way is it going? Since it's dropped, it's going down. So this will be a negative 1 meter. See, down for 1 meter. We also just said that our initial velocity is 0 meters per second. And what's affecting this? Gravity. So that's negative 9.8 meters per second squared. And then we want to know how long will the marble fall. So we're looking for time. So notice these 4 variables, if we go back to our equations, has, let's see, where is it? This one. So dy equals v naught yt plus 1 half gt squared. We have d, which is -1. We have v naught y, which is 0. We're looking for t, and we have -9.8. So in the first video for concept, I told you this will be your best friend equation for the vertical, and it is true. So we want dy equals v naught yt plus 1 half gt squared. So now we're just going to plug in what we know. -1 equals 0 times t plus 1 half -9.8 t squared. 0 times anything is 0, so this becomes 0, so it cancels out. So we're left with -1 equals half of -9.8, which is -4.9, times t squared. At this point, we're going to divide by -4.9 on both sides. Cancels that. And we're left with t squared equals 0.20408. Notice I'm using a number of digits, 3 non-zero, to make sure we get this right. And then to find t, we take the square root of both sides, and we get a t of 0.452 seconds. So keep that number in mind as we keep going. So the next question is, what is the final vertical velocity? So we're looking for Vy when the marble hits the ground. Well, we have all of the same initial, or all the same givens. So we have dy equals -1 meter. We have v naught y, which is 0 meters per second. We have g, which is -9.8 meters per second squared. And now we have time, where time is 0.452 seconds. And now we're looking for Vy, so the final velocity when it hits the ground. I would go with the easiest equation here, which would be Vy equals v naught y plus gt. So now I'll plug in what we know, 0 plus -9.8 times 0.452. So -9.8 times 0.452 gives us a velocity of -4.43 meters per second. Now what does the negative indicate? Indicates it's going down. So negative means down. So does this marble have a velocity in the horizontal direction? So if it's dropped, are we doing anything horizontally? No. So the velocity in the horizontal is equal to 0. So is it going to go anywhere in the horizontal? No, it's not. It's just going up and, well, it's going down. So it's not doing anything in the horizontal. Now let's talk about the difference. So now we're going to launch horizontally. And what we're going to see is whenever we launch this horizontally, it's going to create this nice half parabola. Okay, so it'll create a half parabola. The trajectory of a projectile looks like a parabola, whether it's a half parabola or a full parabola. So for horizontal ones, it's a half. So here we go. Now we're launching this ball horizontally. Initially, there's no vertical velocity. There's only a horizontal. And what I want you to look at is these horizontal velocities. Notice all of these arrows are exactly the same length. And that's because the velocity in the horizontal is constant. Now the vertical, as it falls, the vertical velocity increases. So the arrow length also increases. So 0, small, larger, larger, and larger as it goes. And those velocities create this half parabola. So now, let's see what happens with our math whenever we launch this projectile. So now that it's going horizontally and vertically, we have two component velocities that create an overall resultant. So the components would be your x and your y. The resultant would be the overall. So it's what happens whenever you put those together. which would be that hypotenuse. So now we have Vx and Vy. So let's do the example again. Well, this should look really familiar. A marble is launched at a height of 1 meter and leaves with a horizontal velocity of 3 meters per second. So we're still launching it from the same height as the one we dropped, and we want to know the final vertical velocity. Well, since we've got horizontal and vertical now, we're going to do something just a little different, and that's we're going to do an XY chart for our guess system. So to solve these, it's the same principle. You're going to use your guess method, except now your givens and your unknowns are separated by a chart. So you have your givens in X, your givens in Y, your unknowns in X, and your unknowns in Y. So anything that has an X on it should be under this column. That would be dx, vx, and anything with a y on it should be in this column. V naught y, vy, dy. Now, I told you before that time ties the two together. So time is going to go under both. And there's no tx and ty. It's just time. And then finally, we have gravity. And we said, which one does gravity affect? The vertical. So vertical is y. So gravity will also go over here. So the x column is only going to have 3 variables at any given point, max. The y column will have all of your y's plus gravity and time. So now the marble is launched, and let's set up the xy chart. So we have a horizontal velocity, so Vx of 3 meters per second. So if you want to, what you could do is just do this. Just have all of your variables for everything under your XY chart. Vy, gravity, and time. And then that way, all you have to do is just fill it in. So this is Vx, so this is 3 meters per second. Then we have a height of 1 meter. So which direction does height measure? Height measures the vertical. You don't measure your height horizontally. So the vertical is y. Since this is a distance of 1 meter, it's going to be your dy. Height is dy. Since it's going downward, it's still going to be -1 meters. Now, if it's launched horizontally, we said that this is the same case as a dropped object. So your initial vertical will be 0. Gravity, we always know, is -9.8 meters per second squared. And we're looking for how long does it take to fall. So we're looking for this. And its final vertical velocity. So we're looking for this. This is the same. So this is how you set up an XY chart. So now, to find how long it takes to fall, in the horizontal, we only have one number. We can't solve this for time because we don't have a dx. So we'll have to use the vertical to solve for time. Then we can solve for the vy. So should notice it's exactly the same equations. V naught yt plus 1/2 gt squared. And when you plug everything in, it looks identical to the dropped object. Oh my gosh, it's amazing. T squared. And so you're going to get the exact same time. So time is 0.452 seconds. Same time for a dropped object as for one that's launched horizontally. So now, let's throw that in here. This is 0.452 seconds. So now, if we're looking for Vy, can you guess we're going to use the exact same equation again? Woo! Vy equals V naught y plus gt. And when you plug it in, you get the exact same value. -4.43 meters per second. Yay! So what you should notice is the vertical is identical to dropping an object, but now we've got this horizontal side. So what are we going to solve for? So now we want to know how far it will travel, which means we want to know how far outward it goes, right? Well, that's horizontal, which means x. And so we're looking for dx. Notice our time here is identical. That's because time ties. Time ties the x and the y together. So the time we solve for in the y, we can throw over here in the x to solve for our dx. So now we've got two knowns and one unknown. So we're going to use our only equation in the x, which is dx equals vxt dtv, and we're going to plug everything in. So dx equals 3 times 0.452, and so we get a dx of 1.356 meters. So it'll go a little over 1 meter outward as it was launched horizontally.